Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, I'll be covering precipitation reactions, and we'll learn what they are and how to predict them. Let's get started. A precipitation reaction is a category of reactions where you start off with aqueous solutions, typically ionic solutions, that are combined together, and the result of one of the products is something that is insoluble in water. And so as a result, what you end up seeing is a solid material or something actually crashing out of solution. That's something new being formed. That insoluble product is a thing that we call a precipitate. Now, when we're observing something like what we see here, an example of this, if we have potassium iodide reacting with lead 2 nitrate, those are both two aqueous solutions. They both are ionic compounds, but the ionic compound has actually dissolved in water. Now, when I react those two together, remember, this is a double replacement reaction. So my potassium ions swap places with my lead ions, and we end up creating something new. Now, once we create these new products, now we'll know if a reaction truly has occurred if we see something new being formed. And that's based off of these solubility rules. So we talked about solubility rules in a previous video. If you haven't seen that, go ahead and make sure you check that back out. But if you look at the charts, we would see that potassium nitrate, that new product, we would predict that to be soluble, since there's potassium ions, nitrate ions, no exceptions to those two coming together and making an aqueous soluble material. But now that lead 2 iodide, in that situation, we would predict that that's going to be an insoluble material. And you can see in the picture, you get this yellow stuff that's being formed. Well, the reason we have that is because that lead, the combination of lead and iodine, creates that insoluble material. It's no longer soluble in water. And so since we had something new formed, we can say that in fact, we have a chemical reaction or a chemical change occurring. And so what we're going to do in this chapter is we're going to first learn how to predict the products of precipitation reactions, and then determine if indeed there is actually a chemical reaction or chemical change occurring by looking at the solubility. For a chemical change to occur, you have to have some type of precipitate material being formed, because if not, our ionic material, the things that are, our aqueous material, that soluble material, is still technically just floating around as ions, and we really would not have anything new being formed if both of the products are aqueous. So what we're going to be looking for in this section is the creation of something new, some type of solid or some type of precipitate that's being formed. So there's a process for predicting the products of precipitation reactions. And a lot of these are just based off of the double replacement reactions that I covered in a previous video, predicting the end product at least. All right, so first we're going to look at the reactants that are provided for us and determine what ions are present, okay? And then you would come up with the formulas for possible products. So we're going to swap the ions, swap the cation positions. Remember, that's that A, B, plus C, D format. And so we'd have A and D coming together and C and B coming together, and adjust the amounts, the coefficients, and the subscripts accordingly. And then we're going to be determining the solubility of each product. So now we're going to go back to that chart that I showed in that previous video and look up the solubility for the products, because we know that these starting materials are aqueous. The question is, what will these be? Will they be aqueous? Will they be soluble in water? Or will we get a precipitate? If we do not see a precipitate formed in one of the products, then we would have no reaction taking place. And we'll learn the why that is in a future video when I talk about ionic and net ionic equations. But just again, remember that if we don't have a product that ends up being a precipitate or insoluble, we say no reaction has occurred. All right, so then again, if either of those products are considered to be insoluble, we're going to write that S after it, and that's going to represent the precipitate, and AQ for anything that's soluble, and then we would balance our equation. So let's try an example here. So it says, write the equation for the precipitation reaction of an aqueous solution of potassium carbonate and an aqueous solution of nickel 2 chloride. So potassium carbonate is KCO3 Remember, we would balance this out by saying that this is a 2 negative charge, a positive charge. So bring your 2 down. And it's aqueous, so we write AQ, plus nickel 2 chloride, so NiCl, and it's nickel 2, chlorine ion -1, bring that 2 down, so NiCl2, and that's aqueous. Now we want to swap the cations to predict our new products. And so we would have potassium and chlorine coming together, and we would have nickel and carbonate coming together. Now, when we predict the charges, we see potassium, we know, has +1, chlorine is -1, nickel would still be 2+, and carbonate is 2-. And so in either of these cases, I don't need any subscripts. I do need to balance the equation, however, and we can do that by putting a 2 in the coefficient position. Now, once you've predicted your products, you then want to refer back to that table that I showed in the solubility, those 2 tables that I showed in the solubility video, and determine, will these products be aqueous or insoluble? So if we look up the rules for potassium and chlorine, we would come to the determination that this should be aqueous because potassium, no exceptions, is typically soluble. Chlorine has some exceptions, chloride has some exceptions, but potassium is not one of them. And then if we look at the nickel 2 carbonate product, well, carbonates typically are insoluble. There are some exceptions, but nickel is not one of them. And so we would say that this is a solid material. So because we ended up with a precipitate, this reaction does indeed take place, and we would expect to see something new being formed in this process. All right, let's try 2 more. So we have KCl and silver nitrate, so potassium chloride and silver nitrate. So we have swap the partners again. And so this would be potassium and nitrate are going to come together. And if you're struggling with predicting these products and thinking about the charges that they have, refer back to what they were in the reactants. Whatever their charge is in the reactant side, that's what they'll be on the product side. And so potassium is +1, nitrate is -1. And so we know that we would end up with no subscripts being shown here. And then we would also list our silver and our chloride ion coming together. Again, silver is +1, chloride is -1, so no subscripts are needed, and our equation is now balanced. Now we go back to our chart. Potassium and nitrate come together. We would expect that this should be aqueous because nitrates are typically soluble, no exceptions. All right, and then we look at silver chloride, and we see chlorides are normally soluble except when they're with things like the silver ion. And so we would say that this is insoluble, or write that solid designation. Okay. All right, one more example. We have sodium sulfide and calcium chloride reacting with one another. And so again, the cations are going to swap places. And so we have calcium combining with sulfur. For their charges, we have +2, 2-. We're going to crisscross down, but those would reduce out. So it would just say it's calcium sulfide plus sodium and chlorine coming together, positive and negative, no subscripts needed. We do need to balance this, and we can balance this by simply putting a 2 in the coefficient position. And now we check our products. So for their solubility. And so when we look at our reaction or our solubility rules that was shown in the previous video, we can see that the calcium sulfide, although sulfides normally are insoluble, this would be one of our exceptions. So we would say this is aqueous. And then for sodium and chlorine or chloride ions coming together, that would also be aqueous. And so in reality, since no precipitate is being formed, we actually would say that no reaction has occurred. Okay. So when you see no product being formed, we say no reaction has occurred. We're going to get into the why that is in the future video, but just remember no product, no solid product or no precipitate formed, you write no reaction. I hope this video helped you understand precipitation reactions. Make sure you guys like, comment, and subscribe and come back for more videos. I'll see you guys in the next one. Talk to you guys later. Bye.